Welcome to Creeper Video. My name is Luis Carlo Malinaw.
And Elbers Paul B. Buntor.
Well, today we're going to discuss about another topic in mathematics, which is the laws of exponents.
Also, we're going to discuss on how to apply it.
Well, shall we get started?
Example number 1. X cubed times x squared. Now you can see they are the same base. So we can add the exponent. Equal x cubed plus 2 equal x raised to the power of 5. Here are example number 2. X cubed times y raised to 4. Now you can see they are not the same base, so we cannot add the exponent. So we just copy x cubed and y raised to 4. Here are example number 3. X cubed times x raised to 8. Now you can see they are the same base, so we can add exponent. Equal x cubed plus 8 equals x raised to 11. Here are example number 1. X raised to 4 divide x. Now you can see they are the same base, so we subtract 8 equal x raised to 4 minus 1, then equal x cubed. Now here are example number 2. X divide x raised to 4. Now you can see they are the same base, so we can subtract now. Equal x 1 minus 4 equal x to negative 3, or we can 1 over x cubed. Here are example number 3. X raised to 5 divide x squared. Now you can see they are the same base, so we subtract the exponent. Equal x raised to 5 minus 2. We subtract now, then equal x cubed. Here are example number 1. Quantity of x squared to the power of 3. Now we can just times the exponent. Equal x squared times 3 equal x raised to 6. Here are example number 2. Quantity of x raised to 16 to the power of 3. Now we just multiply the exponent. Equal x raised to 48. Here are example number 3. Quantity of x cubed to the power of 4. Now we just multiply the exponent. Equal x cubed times 4 equal x raised to 12. Example number 1. Quantity of 3x raised to the power of 3. In the law of exponent, you need to cube first the equation inside the parentheses. So, 3 cubed times x cubed, then solve the two equation, which is 3 cubed is equals to 27 and x cubed will remain x cubed since there's no constant, so the final answer is 27 x cubed. Proceeding to example number 2, which is quantity 2x to the power of 2. Same with the number 1. In the law of exponent, you need to square first the equation inside the parentheses. So, 2 squared multiplied by x squared, then solve the two equation, which is 2 squared is equals to 4 and x squared will remain x squared since there's no constant, so the final answers will be 4x squared. Lastly, example number 3. Giving is quantity 5x raised to the negative 3 to the power of 3. Same from the previous problem cube. The equation inside the parentheses. So, 5 cubed multiplied by x raised to the negative 3.
Boom!
Lastly, example number 3. Given is quantity 5x raised to negative 3 to the power of 3. Same from the previous problem cube, the equation inside the parentheses. So, 5 cubed multiplied by x raised to the negative 3 to the power of 3. Then, solve the two equation, which is 5 cubed is equal to 125, and the second equation will be x raised to the power of negative 9. After that, reciprocate the x raised to negative 9, resulting 1 over x to the power of negative 9. Now, the final answer will be 125 over x of... Now, the final answer will be 125 over x to the power of 9. And here is Luis Carlo to give some other rule and example about the law of exponent.
Now in this part, we would be discussing about the power of fraction rule. But first, what is the power of fraction rule? The power of fraction rule is another way you can simplify an algebraic expression with exponents. For example,
example number 1. Now, the power of quotient rule states that the power of quotient is equal to the quotient obtained when the numerator and denominator are each raised to the indicated power separately before the division is performed, just like this. Example number 2. Now, consider 4 over 2. Okay, it's equal to 2, but for the moment, let it stay as a fraction. And let us calculate it with the rule first. Let us now solve the fraction first and raise to the power of 2, which is this one. So, it goes like this. Now, example number 3. This rule is particularly useful if you have more difficult problems, such as algebraic expression with letters, such as this equation. Consider this as one of the most difficult problems in algebraic expression. Now you can write it as and this is the final answer.
Now, let's move on to another topic, which is the zero exponent rule. The zero exponent rule basically says that any base with an exponent of 0 is equal to 1. For example,
example number 1. I know that negative exponent means that the base, the x, belongs on the other side of the fraction line, but there isn't a fraction line. To fix this, I first convert the expression into a fraction in the way that any expression can be converted into a fraction, by putting it over 1. Of course, once I move the base to the other side of the fraction line, there will be nothing left on top. But since anything can also be regarded as being multiplied by 1, I leave a 1 on top. Here's what it looks like. Example number 2. Only one of the items or terms has a negative exponent. This means that I'll only be moving one of these terms. The term with the negative power is underneath. This means that I'll be moving it up top to the other side of the fraction line. There already is a term on top. I'll be using exponent rules to combine these two terms. Now, once I remove the denominator up top, I won't be having left underneath. So I'll drop the denominator. And is what it looks like. Example number 3. The negative power will become just 1 once I move the base to the other side of the fraction line. Anything to the power 1 is just itself, so I'll be able to drop this power once I move the base. Make sure you understand why the 2 above does not move with the variable. The negative exponent is only on the x, so only the x moves.
In this part, negative exponent says that negative exponents in the numerator get moved to the denominator and become positive exponents. On the other hand, negative exponents in the denominator get moved to the numerator and become positive exponents. Reminder, only move the negative exponents. For example, and lastly, the fractional exponents. A fractional exponent is an alternative notation for expressing powers and roots together. For example,
Example number 1. This is the power. This is the root index. For our purposes, it doesn't matter if you write the second power on the 8 or on the cube root. It goes like this. Because the cube root of 8 is 2, I prefer to take the root first and then apply the power. Of course, the other order yields the same result. So this is the final answer. Example number 2. This is equivalent to 2 raised to the 5th of 4th power. So it can be also written as, if we want to, we can manipulate the above expression even further. Begin by recognizing that 5th over 4 is equivalent to 1 plus 1/4. So it goes like this. Using exponent properties from lesson 29, we can split it into 2 expressions involving base 2. Goes like this. From there, drop the power of 1 since it isn't necessary, and rewrite the 1/4 power as a root index of 4. Also feel free to drop the multiplication symbol. Goes like a little bit like this. And that is the final answer. Example number 3. Simple as that.